What up, everyone? This is LeetCode 572, subtree of another tree. So basically we have a subroot and we have to check if it exists in this root tree. And it has to exist structure with the same structure and the same node values. For example, here, the subroot exists here. Structurally, it's the same, right? And it has the same nodes. So we'd return true. Now, what do I mean by this subroot has to be structurally the same as this root? What I mean is, like, this structure here has to exist exactly like this. So I'll show you an example where that's not true, right? Here, the subroot exists here, but it's not structurally the same because it has actually a 0 here, this node here, right? And that doesn't exist here. So this would return false because structurally the subroot is not the same this subroot is not structurally the same in this root, okay? So that's what I mean. So yeah, basically same nodes and the same structure. Okay, that's basically the two things we need to handle. And also it says here the tree could also be considered as a subtree of itself. So basically that's just telling you that basically if we have no root and we have no subroot, then we return true because a subroot of nothing, let's say our root is nothing, right? Nothing is a subroot of nothing, if that makes sense. Okay, that's basically what it's telling us. So if the root is none, then then the subroot of none is just none, right? So if they both don't exist, we would return true. Okay, now if we don't enter and return that, but one of them is missing, then in that case we return false, right? Because if root exists and subroot doesn't, or vice versa, then how can we have one be a subroot of the other, right? It wouldn't make sense if one of them doesn't exist. Okay, so that's the case where we return false. So these are just really just edge cases we have to handle. Okay, now let's handle actually comparing and seeing if the subroot exists in the root. So let's do this. We're going to have to define a function, okay? And basically, we're going to have to compare and check, okay, how is some particular structure here the same as the subroot? Okay, how do we do that? Okay, so the way we do that is we're going to just say if self is same tree, and we're going to pass it the root, we're going to pass it the subroot, okay? And we're going to return true if that yields us a true result if we enter this statement. Okay, and so we're going to pass it a root and a subroot, and we're going to have to check a few things. Okay, so if p is none and q is none, we return true, because that would be a case where, let's say we're at this one and we go left, we're at this one and we go left, they would both be none, and so that means we basically have nothing more to check, so it would return true. Okay, now if we have, for example, p is none or q is none, that's a case where we would return false, right? Because that's a case where they're not structurally the same, right? For example, we're at this 2 and we go left. This p node exists, we go left. This q node does not exist. Okay, this is basically where we're breaking our rule that they have to be structurally the same. So they're not structurally the same in cases where p exists but q doesn't, or vice versa. So that's a case where we would return false. There also is another edge case though, which is where the values are not the same, okay? Because again, to be a subroot of the root, they have to have the same structure but also the same node values. Okay, so that's what we're doing. We're checking the structure and we're checking the values. That's what we're doing. Okay, now down here we're going to say return self dot is same tree. I'm going to say p dot left, q dot left, and self dot is same tree, p dot right, q dot right. So we would actually enter this return statement in cases where both nodes exist and they have the same value. So yeah, and we'd basically keep going left and keep going right to continue checking that they have the same structure and the same values. Yeah. And then down here, okay, this is where we actually recursively call the actual function that we started in. So we're gonna say is subtree. We're gonna say root.left subroot or self dot is subtree root.right subroot. Okay, now I'm gonna run through this first example just to kind of make sure you understand what's happening in the code. So we wouldn't enter these edge cases in example 1 because root and subroot both exist. Okay. So we would enter this statement though. Okay. So we'd pass root and subroot, which is obviously 3 and 4. That's our head nodes. 3 and 4. Well, we would actually enter this and return false because p.val is not equal to q.val, right? 3 is not equal to 4, so we'd return false. So we would go down here. And again, we're looking for the subroot anywhere in this root. That's why we either go left or we either go right. And we only need to return true in one of them because obviously if the subroot exists here, it doesn't mean it exists here. So we only need to return true once. Because again, our subroot can be anywhere. That's why we have to check both directions, obviously. So we're gonna go root.left, okay? And again, we're recursively calling this function, the same function. So we go back in this function again, but we go root.left, so we go with this 4. Okay, we wouldn't hit the edge cases. We would do pass this node into the root and the same subroot, so 4 and 4. They both exist. And they both have the same values, right? 4 and 4. So we actually go to the return statement and we go left. And again, 1 exists. We also go to the right from this 4, right? Both these 2's exist. And then when we're at this 1 and we go left and we go right, when we go left and we go left, they're none, right? So you'd return true. When we go right and we go right, they're none, right? So we return true. Okay, so we're not actually going to hit a case where we return false because obviously that's what our code should do, right? This is an actual subroot. This right here is actual subroot. The subroot is equal to this subroot here, right? So the subroot does exist in root, and this is where it exists. Okay. So yeah, that's how basically we're doing the checking. Yeah, I don't think this code is too complicated. I think there's another LeetCode problem called is same tree. I don't remember what LeetCode problem it is. You're gonna have to look it up, but it's very similar. It's basically the same concept. Basically, I think you're just checking if 2 trees are the same. Except with this, you're taking a step further. And you're checking if a subroot is the same as if a subroot that you're given exists in the given root that you're given, or in the given tree you're given. So that problem's pretty similar. I'd recommend that one if this one's a little bit hard, but honestly, I went step by step. I think this one's not too hard to understand. You just kind of have to know how we're checking whether the subroot exists or not. Again, we're just checking the structure and the node values. That's all we're doing, right? And if none of those are true, then we're just returning false. And we're checking throughout the entire tree, throughout this entire root if the subroot exists. And once we check all those nodes, if we find nothing, we just return false, obviously, because this would return false. If the subroot exists, then at some point one of these will return true, and yeah, the whole function will just return true. So yeah, this problem isn't too difficult. It's just a little bit. You just got to think about it a little bit slowly and go through it piece by piece. But yeah, I hope this helped. And also, there's a lot of ways to solve this problem. I mean, you can use DFS. I've seen people do I've seen people convert this tree into a string, and same with this one, and check if this string is within this string. I mean, you can handle this problem in so many ways. So, but yeah, this is just like the basic DFS way to handle it. But anyways, I hope this helped, and I'll see you in the next one.